All right, good morning, class. Let's take a look at your 9.7 worksheet here, dealing with graphing rational functions. So on all of our problems here today, one of the things we want to do is we want to, as it says, whoops, I'm on eraser here, is it says to find all your asymptotes and all your holes for each rational function, and then finally you're asked to sketch the graph on these 5 problems. So when I go about doing these problems, what I need to do is identify the holes and asymptotes really right away. So that's going to help me graph it. So I'm going to write holes, I'm going to write horizontal asymptote, and I'm going to write vertical asymptote. And I'll do that for all 5 of these problems. The first thing that I do is once I want to identify those, is I take a look at the rational function and see whether or not it's been factored, or it's in factored form. This one's really nice because it's actually in factored form. So it saves you the first step. Now, once you have it in factored form, the next thing you want to deal with is, or look at is, identify any factors that are in both the top and bottom, because that's going to determine your holes. So what I have is I have a hole when x minus 3 equals 0. Because I can't divide by 0, so that factor can't equal 0. So I set it equal to 0 to find out where there's going to be a hole in the graph, where it won't exist. So I have a hole at x equals 3. Now, to find the rest of the pieces, when I talk about my vertical asymptote, this is going to, what I'll do is I'll take the other factor, x plus 4, and set it equal to 0, because I know that I can't divide by 0 also. I'm going to subtract 4 from both sides. So I get x equals negative 4. That's where my vertical asymptote is going to be. For my horizontal asymptote, that's where we do the power test. Basically, the power test is to get the horizontal asymptote, it's going to be y equals, I simply take the highest degree polynomial divided by the highest degree polynomial, meaning, or the highest degree term of each polynomial. So if I were to distribute here, I'd have x squared plus 3x. X squared is the highest, so that's going to be in the top. Likewise here, if I FOIL, I'd have this x squared plus 4x minus 3x minus 12. The highest degree, again, is this x squared. So I'm dividing x squared by x squared, which is this itself, so I have a horizontal asymptote at y equals 1. Now, once I have these have these identified, I can start sketching the graph. So the first thing I start with is the horizontal and vertical asymptotes. I have a horizontal asymptote at 1. I have a vertical asymptote at negative 4. Now the question becomes, does this rational function belong in quadrant 1 and 3, or does it belong in quadrant 2 and 4? Okay? Because we know that it's going to be an inverse function, so it's going to be in one of those sets of quadrants. So the question is, how do I go about finding it? Okay? Probably one of the easiest ways to find it is to test a point. And so what I do is, since none of these values is 0, is I'm just going to simply let x equals 0, plug it into here. If I do, in the top, I get 0 times negative 3. In the bottom, I get negative 3 times 4. So negative 3 times 4 times 4. So now if I simplify this, I get negative 3 over negative 12, which reduces to 1/4. So at 0, when x is 0, the y value is 1/4, which is right here. So that tells me I'm going to be in quadrant 4 and in quadrant 2. Now when I sketch this, The other thing I need to be aware of is my hole at 3. So when I go to 3 here, I'm going to have a hole. So when I sketch it, it'll look like this and something like this. All right, that takes care of number 1. All right, moving on to number 2. Number 2. Again, I'm going to think about my holes, my vertical. So I'm going to think about with number 2, my holes, my vertical asymptote, and my horizontal asymptotes. So now, to start this out, I need to factor it. X squared minus 4x actually has a factor of x in common. So when I factor that out, I'm left with x times x minus 4. So what that tells me is since the factor x minus 4 repeats, that's where a hole will be located. Since I can't divide by 0, I take x minus 4 and set it equal to 0, solve for x equals 4. So I have a hole at x equals 4. Now here's the thing. That's my only common factor. I don't have anything else in there. So there are no other vertical asymptotes. There are none. Okay? Now for my horizontal asymptotes, I take my highest degree over highest degree. So I have y equals x squared over x. Well, that ends up being x. Well, that means x could be any number. So since it can be any number, we don't have any horizontal asymptotes. So now the question is, what does the graph actually look like? Well, what will happen is your x minus 4 and your x minus 4 would technically simplify out, and you'd be left with the graph y equals x. Well, that has a y-intercept of 0 and a slope of 1. So I just keep on going 1, 1. However, I know I have a hole at 4. I would have a hole at 4, or I could go down 1. So I basically have a graph to a line, but it has a hole here at 4. All right, let's continue on. Number 3. Excuse me. So when we take a look at number 3 here, we're going to factor the top and we're going to factor the bottom. So if I factor the top, I have x minus 5, x plus 1. Again, I'm looking at factors of negative 5 that add up to negative 4. X squared minus 1, those are both perfect squares, so I have x minus 1, x plus 1, x minus 1. So now when I'm looking at this one, I'm going to go and identify the holes, the vertical asymptotes, and the horizontal asymptotes. So in this particular case, for my holes, my x plus 1 is a common factor. So I'm going to set that equal to 0 since I can't divide by 0. So I have a hole at x equals negative 1. For my vertical asymptote, I take the other factor that's left in the denominator and set it equal to 0. So I have a vertical asymptote at x equals 1. On my last one, horizontal asymptote, again I take the highest degree over highest degree. This one's pretty nice because I'll have x squared over x squared, which is equal to 1. So my horizontal asymptote is also at 1. So I can go ahead and sketch both of those asymptotes at 1 and at 1. And now I need to figure out, am I graphing this in quadrant 1 and 3, or am I graphing this in quadrant 2 and 4? So what I can do is I can plug in and test a point. So again, what I like to do is I like to let x equals 0. And I like to go back to the original function. Because every place at x, you have an x, that turns into 0. So what ends up happening is those all cross out, and I get y equals -5 over -1, or y equals 5. So when x is 0, y is 5. So 1, 2, 3, 4, 5. So I know I'm in quadrant 2 and 4. Now again, remember, we have a hole at -1. Okay? So I'm going to put up here at -1, I'm going to have a hole in my graph. So my graph's going to look something like this, and something like, oops, this. It's kind of a wild sketch there. All right, that was number 3. Number 4. Same process, we need to factor first. So if I factor this, I have x plus 6, x minus 6, difference of perfect squares. The other one, factors of 12 that add up to 8. Well, that would be 2 and 6. So now, for my holes, do I have any factor that repeats? Sure enough, x plus 6. So x plus 6 equals 0. Subtract 6, and x equals -6. So I have a hole at x equals -6. Need to find the vertical asymptotes. So I take a look at just the other factor that's in the denominator, which is x plus 2. Set that equal to 0. So x equals -2. So vertical asymptote, x equals -2. For the horizontal asymptote, I take the highest degree, which is x squared, divided by the highest degree, which is x squared. Remember, that's what y is going to equal. So my horizontal asymptote here is y equals, again, 1. So I can go ahead and start sketching it. So I first start with horizontal asymptote at 1, vertical asymptote at -2. So now the question becomes, I'm going to have a hole at -6, got to remember that, but I need to test 0, 0. Well, that's nice about this, again, this would be gone, this would be gone, and that would be gone. So y would equal -36 over 12, or y would equal -3 when x is 0. So I know the point 0, -3 is on the graph. So if I go 0, -3, there's a point. So now I know that this graph opens up in quadrant 4 and quadrant 2. So when I go to quadrant 2 here though, -1, 2, 3, 4, 5, 6, I'm going to have a hole. And I got my graph. All right, the last one here, number 5. When I take a look at number 5, just give myself a little room, I need to factor this one first. So when I look at the top, notice how they all have a power of 2. So I'm going to start with that. So when I factor out the 2...
Pardon the interruption. There's a dark blue Honda Odyssey van in the student parking lot.
Pardon the announcement there. So if I factor out 2 first, I'm left with x squared plus 7x plus 12. The bottom factors nicely to x plus 4, x minus 3. Now here's the nice thing about this x squared plus 7x plus 12. I'll move this over here since I'm running out of a little space. Factors of 12 that add up to 7. So now I have this x plus 3, x plus 4 all over. And I apologize, this is wrong here. This should have been a 2, not a 3. Some of you might be going, what? Where'd you get that, Mr. Bartz? So luckily I caught that there. So I have x plus 4, x minus 2. So now we can go about our business of finding the holes and such. So for a hole, we know the x plus 4's repeat. So x plus 4 equals 0, x equals -4. So I'm just going to write them here. Hole at x equals -4. Vertical asymptote, take the other one. X minus 2 equals 0, so x equals 2. We got vertical asymptote at x equals 2. Horizontal asymptote, that's where we take the highest degree over the highest degree. So in this case, y equals 2x squared over x squared. So here the x squareds cross out, and it's at y equals 2. So let's go ahead and graph those asymptotes. So I know they're both at 2. So I got dot, 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 dot. And at 2, dot, 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 dot. I'm going to have a hole at -4, but what I want to do again is I'm going to test it when x equals 0 to find a point. Remember what happens here, crosses out, crosses out, crosses out, crosses out. So y actually equals 24 over -8, which is -3. So when x is 0, y is -3. That tells you that you are in quadrant 1 and 3. So when I go ahead and sketch it, just got to remember I have a hole at -4. So here at -4, I'm going to put a little hole. So here's my graph. And there's my other graph. And that completes our worksheet.